of reconstructing the hyperbolic functions. And the key lies in the following fact. It lies in the fact that the derivative of e to the u with respect to x is e to the u times du dx. In particular, if I take the derivative of e to the t with respect to t, I get e to the t. If I take the derivative of e to the minus t with respect to t, I get what? E to the minus t times the derivative of minus t with respect to t. That's minus 1. So the derivative of e to the minus t is minus e to the minus t. Well, what does this have to do with anything? Notice that if I now construct a new function, e to the t plus e to the minus t, since the derivative of a sum is the sum of the derivatives, notice that this result here tells me that the derivative of e to the t plus e to the minus t with respect to t is e to the t minus e to the minus t. Okay? Now, let me do this operation once again. Suppose I now take e to the t minus e to the minus t, and I differentiate that with respect to t. Well, the derivative of e to the t gives me e to the t again. The derivative of e to the minus t is minus e to the minus t. Minus times minus is plus. So observe that if I differentiate e to the t minus e to the minus t, I come back to e to the t plus e to the minus t. Notice already how this starts to behave, at least a little bit, like our friends sine and cosine, except again for a little change in sign. Namely, if I give this function here a special name, and to make it suggestive, I'm going to call it c of t. C sort of to indicate cosine, but I don't want to write cosine because it's not a cosine. Let me just call this function here c of t, and its companion, as you may guess, I will call s of t. C of t is e to the t plus e to the minus t. S of t is e to the t minus e to the minus t. This pair of functions has the property that what? The derivative of one of them is always the other, which is not quite what sine and cosine did. Remember, if you differentiated the sine, you got the cosine, but if you differentiated the cosine, you didn't get the sine, you got minus the sine. So you see, again, a similarity, but not exactly the same thing. Nonetheless, we get a little bit suspicious about this. We see that the derivative of c is s, derivative of s is c. We remember that there was a basic identity involving sine squared plus cosine squared. We might get the premonition that maybe there's some relationship between s squared and c squared. And one of the best ways of checking out a premonition is to just check it out. I mean, let's just see what happens. In other words, starting with this definition of c, this is a binomial, let's square it. You see, if we square it, it's what? It's e to the 2t, the first term squared, plus twice the product of these two terms, but e to the t times e to the minus t is e to the 0, which is 1, plus e to the minus t squared, which is e to the minus 2t. In other words, putting this